We are going to go over, this is the explanation of the volume assessment. This is the pre-assessment, and we are going to go over finding the volume of objects with two bases, one base, and no base. That no base is a sphere. So the first one that we want to look at is we have to look at this and find, we see that it's a two base figure, and now I have to sort of set what my base is going to be. So my base is going to be this bottom, and that's going to be 3 miles, and then this distance here is going to be 4 miles. If we look, and this is kind of confusing, so I find it, and then I find a parallel line to it. So it's 3 miles by 4 miles is my base. Remember that the volume formula for all two base figures is V equals big B times H. So my base shape is a rectangle, so I'm going to have base times height times the height of the object. This height is always going to be the height of the object, and these are going to be the area of the base. So the base of that base is 3 miles. The height is going to be 4 miles. And then the height of the object, that's the distance between the two bases. That's going to be this distance, is going to be 3 miles. So we'll multiply 3 miles times 4 miles, which gives me 12 miles squared. We're going to multiply that by 3 miles, which gives me 36 miles cubed. Pretty straightforward. Let's look at the next object. We again have a rectangular base. Let's select what we want my base to be. I'm going to pick this bottom to be my base, and then its identical parallel base would be up on the top there. But since I have two bases, volume equals big B times H. Shape of my base is a rectangle again. And then the base of that rectangle would be 11 yards. And the height is going to be 2 yards. And just to remind, it's this line, and then we look and see, okay, oh, there we go, 2 yards. So I'm looking for that if I don't have the unit near on my base, I have to find out what that measure is. And then 8 yards is going to be my height of the object. That's the distance between the two bases. So I have 8 yards. So 11 yards times 2 yards gives me 22 yards squared times 8 yards. And 22 times 8 gives me 176 yards cubed. Now we move on to, it's still two bases, but we're going to look at that base shape. That base shape this time is a triangle. So we're still using volume equals big B times H. The base shape this time is a triangle, and the area of a triangle is base times height divided by 2, and then times the height of the object. So that base of the triangle, remember the base and height have to be perpendicular, and the base has to be a side of the triangle. So I'm going to choose 6 centimeters as the base. Perpendicular to that, going from the base to the top of the object, would be 8 centimeters divided by 2. And then I'm going to multiply it by the height, and that's the distance between the two bases, which would be 10 centimeters. We can do 6 centimeters times 8 centimeters, which gives me 48 centimeters squared. Divided by 2 gives me 24 centimeters squared times 10 centimeters, which gives me a total of 240 centimeters cubed. That would be the volume of that triangular prism. Now we move from prisms to pyramids. We only have a single base. That single base shape is a square, or we can also call it a rectangle. All squares are rectangles, but not all rectangles are squares. So the volume formula for single base figures, pyramids, is 1/3 times big B times H. So the shape of the base is a rectangle, so we have base times height. And now we start filling in the pieces. So volume equals 1/3. The base is 4 kilometers, and the height of the rectangle, meaning this bottom piece, is 4 centimeters. And now the height, we're going to multiply it by the height. Remember, the height has to be perpendicular, and it goes from the interior of the pyramid. So it's still from the base to the top of the object, and that's going to be 6 kilometers. 1/3, 4 kilometers times 4 kilometers gives me 16 kilometers squared times 6 kilometers. And here's where we're going to do some efficiency. We have 1/3 times 16 times 6. I can cancel that denominator with this numerator. And that's much more efficient. And now I'm just multiplying 16 kilometers squared times 2 kilometers squared, which gives me 32 kilometers cubed. So that is the commutative property. We're multiplying across the board. We can cross-cancel that denominator with a multiple, a like multiple. Let's look at the next problem. Now we have another rectangular pyramid. There's my base, which is a rectangle. So we're going to use the volume 1/3 big B times H. Big B represents my base. My base shape is a rectangle, so I'm going to do base times height times the height of the object. The base I'll use as 9 kilometers times the height, which is 8 kilometers. And then the height of the object is 12 kilometers. Now we see we have 1/3 times 9 times 8 times 12. I could even cross cancel at this point and do that. That's okay. I could have also canceled the 3 with the 12 instead of the 9. Not both of them, just instead. So now I have 3 kilometers times 8 kilometers, which gives me 24 kilometers squared times 12 kilometers, which is going to be a big number. 24 times 12, which is 288 kilometers cubed. Now we have a triangular pyramid. Still, volume equals 1/3 times big B times H. All formulas for pyramids and cones, single base figures, is going to be volume equals 1/3 big B times H. What's my base shape? It's a triangle. So I'm going to fill in the area for a triangle formula. The base of that triangle is going to be 8 feet. I'll choose 8 feet, and the height is going to be 6 feet. Remember, they have to be perpendicular. I can't use 10 as any of the bases or the height because I don't have a perpendicular height for 10 feet. So I have to choose 6 and 8. And then the height of the object is 10 feet, that 10 feet. Here we go. I have 1/3 times 8 feet times 6 feet divided by 2 times 10. So I can cross cancel here. I can cancel this 3 with the 6 and make that 2. I could cancel the 2 with the 8 or the 10. I'm going to cancel it with the 8 and make it 4. So we're left with 4 feet times 2 feet times 10 feet. So 4 feet times 2 feet gives me 8 feet squared times 10 feet gives me a final volume of 80 feet cubed. Cross cancel. I mean, you can multiply out and you just get bigger numbers. But since we know how to multiply and cross cancel and simplify, let's do that. Now we move back to a two-base figure. We've got two bases, which are circular. So we're still, since it's two base, we revert back to volume equals big B times H. The base shape is pi r squared. It's a circle. Area of a circle is pi r squared. We're going to use 22 over 7 for pi. Why? Because we have a multiple of 7. My radius is going to be 7 feet quantity squared times the height of the object, which is 11 feet. I have to square. I got to do the exponent before I cross cancel those 7s. I have to do exponents first. 22 sevenths times 49 feet squared times 11 feet. Now I'm going to cancel. 7 goes into 49 7 times. So I have 22 times 7 feet squared times 11 feet. I'm going to multiply it 22 first. I think is 154 feet squared. Let's make sure. 22 times 7, 154. Good. And then I'm going to multiply that by 11 feet, which should give me 1694 feet cubed. 154 times 11 gives me 1694. Yes. And that is using 22 over 7 for pi. What if I use 3.14 for pi? I would still do pi r squared. Let's do 3.14 times 7 feet quantity squared times 11 feet. So we're going to get 3.14 times 49. Whoa. 49 feet squared times 11 feet. 49 times 3.14 gives me 15386 feet squared times 11 feet gives me, oh good, I got some space here. Let's see if I can do that. It's going to be 168. Does that become 9? Yeah, 9. No. 9. 1. I don't know. Let's just use a calculator. 153.86 times 11. That's a lot of numbers. Oh, it was 1692.46 feet cubed. So pretty close. Actually, not really close. That is, I mean, it's less than 2. It's about 2 away, so that's interesting. Our next object is a cone, circular base. It only has one base, so we're going to use 1/3 big B times H. My base shape is a circle, so we're going to use the area of a circle, which is pi r squared. We're going to use 3.14 for pi, because my radius is 5 squared times the height, which is again 11 kilometers. 1/3. We're going to multiply, well, we're going to square 5 kilometers, and that gives us 25 kilometers squared times 11 kilometers. I'm going to do that one out because I can do it in my head. 3.14, 25 times 11 gives me 275 kilometers cubed. I'm going to multiply 275 times 3.14, which equals 1/3 times 863.5 kilometers cubed, and then I'm going to divide it by 3. And my answer is 287.83 repeating kilometers cubed. And the last one is a sphere. Sphere has no bases, so my formula for volume is 4/3 pi r cubed. Oh yeah, cubed. I'm going to use 3.14 for pi. And then we've got this decimal. Whoa, I don't think we've done a decimal yet. Cubed. So we have 4/3 times 3.14. Let's do 4.2 cubed caret 3 gives me 74.088 yards cubed. We're going to multiply that by 3.14. We're going to have some crazy decimals in this problem. And that gives me 232.6363. So it didn't round it. That's really interesting. And now we're going to multiply it by 4 and then divide by 3. And that volume, my final answer is 310.18176. I don't know if that's repeating or anything like that, but that's as far as my calculator goes out to. Ooh, I forgot yards cubed there. Yards cubed. That is a large number. Not a big number, but it goes out to a large place value. Hopefully you got those correct. Let me know in the extra help time. Good luck on the assessment, and let me know if you have questions.